This question asks, which of the following statements about a Grignard reagent is true? So Grignard reagents, we know, react with lots of different types of molecules, different types of carbonyl-containing molecules like ketones and aldehydes. And here we're talking about Grignard reagents reacting with carboxylic acid derivatives. So let's take a look at our answer choices. So first off, we have Grignard reagents react with acid anhydrides to form aldehydes. So in this question, we have to think about what is an acid anhydride, and then what would the product of this reaction be? So an acid anhydride looks like this. And then we want to think about what happens when the Grignard reagent reacts with it. So say we have our R coming in to react. We know that it's going to come in and attack the alpha carbon, or not the alpha carbon, sorry, the carbonyl carbon. And we're going to push up that set of electrons. And then the next step is loss of a leaving group. So we reform the carbonyl to make a ketone. And then that ketone is susceptible to reaction again with the Grignard reagent. So we have kind of two reactions take place where we make two different tetrahedral intermediates. And then the last step is just proton transfer, usually with some kind of an acid, for example. And in this instance, we make a tertiary alcohol as our product. All right, so this first statement we can say is going to be false because it doesn't make aldehydes, it makes a tertiary alcohol. All right, let's take a look at our second example. I'm going to erase the mechanism here so we can kind of think about answer choice, the second answer choice. And it says Grignard reagents are more reactive than Gilman reagents. So you kind of have to remember what is a Gilman reagent. The Gilman reagent is basically an organocopper compound where you're going to have some kind of an R group with your copper here and then some kind of counter ion. So in this instance, the Gilman reagent basically has kind of like an R to copper bond versus the Grignard reagent. Which has a R to Mg bond. Okay, and so there is a difference here. The Grignard reagent is more reactive because we have a kind of a more polarized bond with the R to magnesium versus the Gilman reagent, which is an R to copper bond. So statement number 2 is true. We are more reactive than Gilman reagents, the Grignard reagent is. It's a stronger carbon nucleophile. All right, next up, let's take a look at statement number 3. Statement 3 says that Grignard reagents add twice to esters, but only once to acid chlorides. So acid chlorides react just like the acid anhydrides do. So if you have your acid chloride and you bring in your Grignard reagent, we see this kind of first reaction to make a tetrahedral intermediate. We kick off the chlorine, we form a ketone, and then the Grignard reagent comes in and attacks again. So we know right away that this statement is false because we are going to add 2 times to our molecule here. And the final product is essentially a tertiary alcohol, just like we saw with the acid anhydride. So tertiary alcohol, and so the once part there is false. All right, let's take a look at the last statement, statement 4. It says Grignard reagents can be used to synthesize secondary alcohols from ketones. Okay, so if we take a ketone like this and we bring in our Grignard reagent, the Grignard reagent is always going to be forming this new carbon-to-carbon bond. And so we're not really going to be able to form a secondary alcohol in this instance. We're making tertiary alcohols. Like so. And so this one is also false because we don't make secondary alcohols. We again make a tertiary alcohol as our product. Okay, so let's take a look at our answer choices. We have 1 only, 2 only, 2 and 4, 1 and 3, 1, 2, and 4. So the question is asking which of these statements is true? So only one statement is true, and that's 2. So the answer to this question is B.